And here's the third homework for the Introduction to Mathematics course. This one on relations and graphs, so mainly equivalence relations though. In exercise 1, I'll give you 3 graphs and your task is to either find an Euler circuit in these graphs or show that none exists. So this is a rather easy warm-up. If you go back to the chapter 5 of the course, you will find something that will help you do this rather easily. Exercise 2 is about equivalence relations. So here we introduce the symmetric difference of two sets, x and y. We use this notation, x delta y. And this is defined as x without y union y without x. So this is in fact the set that contains all elements of the sets x and y that are not contained in the respective other set. And then we define a relation on the power set of the real numbers by saying two subsets of the real numbers are equivalent if their symmetric difference is finite. So, in other words, if the part where these sets do not coincide is only finite. And you have to prove that this is an equivalence relation. And in exercise 3, this is also about equivalence relations. So here we consider the following set x, the integers times the positive natural numbers. And we define a relation on this Cartesian product here, where the first entry is an integer, the second one is a positive natural number. And two such pairs are deemed equivalent if Zn times n2 equals Z2 times n1. Okay, so this one here multiplied by that one equals this one multiplied by that one. And if that's the case, they're considered to be equivalent. And you're supposed to show first that this is in fact an equivalence relation. And yeah, perhaps you already see what's going on with these pairs of numbers here, but in part B of the exercise, you have to find a bijective map from the quotient set of this equivalence relation to the rational numbers. Okay, so this means you can actually identify the quotient set with the rational numbers. And the last exercise is just to get a little bit acquainted with modular arithmetic. So here we are just doing modular arithmetic over with modulus 6. And I just want you to complete the following arithmetic tables for the arithmetic in Z over 6z. So these are the elements of Z over 6z. And yeah, of course, the first table in every entry here is if you take the row entry and the column entry and you add them together, what would be here. And weirdly enough, my PDF reader always interprets this as phone numbers. I don't know why. Anyway, and the second table, you do the same thing but with the multiplication. And to help you a little bit, I pre-filled a few of the entries here. So if you have some difficulty understanding it or you're not sure if you understand it correctly, then you can check with the entries that are already in here if they match your understanding. And well, if not, maybe take a second look at the video I made on equivalence relations. And part B of exercise 4, here we have an element x in Z over 6z given. And you have to find out for which of these elements does there exist a multiplicative inverse element. So that means some other element x prime such that x times x prime equals 1. A little hint, you can actually quite easily find this from this table if you completed it. And yeah, that's it for the third homework exercise.